Hi. So, we will talk about order statistics. So, the problem is to find the, we have given an array of n element, and the problem is to find out the ith smallest element. Need to find the ith smallest element from this array. So, if I is equal to 1, this is the minimum, and for I is equal to n, this is maximum, and for I is equal to n by 2, I mean either lower ceiling or upper ceiling, n need not to be a or even number always. So, this is called median. So, this is our problem, how to find out the ith smallest element from a given array. Okay, so, we define the rank of a element in a array. Rank of an element means the position of that element in a sorted array. Suppose we have the number like this 6, 5, 2, 1, 9, 8, 7. Suppose this is our input, this is an array. Now, if we sort this array, we will get 2, 1, 2, 5, 6, 7, 8, 9. So, if we ask what is the rank of 6, rank of 6 is 4. That means, the position of that element in a sorted array. And if we trying to find out the fourth smallest element, and that should return us 6. So, for the ith smallest, finding the ith smallest element means we are trying to find an element whose rank is I. So, how we can do that? The naive approach is we can sort the array first, and then after sorting we can go to the ith position and we can return the AI after sorting. So, this is the, so what is the time complexity for this? So, we are applying a sorting algorithm. So, if you use the merge sort or heap sort, which is n log n, and then this will take constant time. So, it is basically n log n plus theta of 1. So, this is basically order of n log n. Okay. So, now we want to do something better than this. Actually, we want to do a linear time algorithm for finding the ith smallest element. So, how we can do that? So, we will try to use, we do not need to sort all, because we can just, because we do not, if we sort we will get all the smallest element like this, but we do not need that, we are only trying to get the ith smallest element. So, what we do? We will apply the partition algorithm of quick sort. Okay. So, suppose this is our select, we have given array and we are trying to find out the ith smallest element. So, now what we do? We just call the partition algorithm of quick sort. Say our array is say P 1 to Q. Okay. So, it will return. So, it will store the pivot element, which is basically AP, because our original partition algorithm we take the pivot element as the first element of the array, which is basically AP. Now, it will store this x and all the elements over here is less than x, all the elements over here is greater than x. So, we define this k is equal to p minus r minus 1, sorry, plus p minus, sorry, this is r minus p plus 1. Okay. So, this is basically nothing but rank of this x. Okay. So, it is returning the r position of that array, and array is starting from p. So, the position of this element is r minus p plus 1, that is the rank of the pivot element x. Now, so we are looking for ith smallest element. So, if I is equal to k, then we are done, we are lucky, return just x, that is the ith smallest element we are looking for. Else, if I is less than k, that means we are looking for a small element whose rank is less than rank of this pivot element. So, that element must be here. So, that is the divide step. So, now we have to look for that element in this subarray. So, then we call this select a p comma r comma I. Okay. Otherwise, if I is greater than k, that means suppose this r is say 5 and we are looking for 9th smallest element. So, 9th smallest element will be this side, this subarray. So, we have to look into this subarray, but with I is not 9, because we have already come across with rth smallest. So, we will look at I minus kth smallest. So, then we call this comma q I minus k, because we have already seen the rank of this element. So, after that in this subarray we have to look at the smallest element. So, this is the code for finding the ith smallest element. We are using here the partition algorithm of quick sort. Now, let us quickly analyze this code. Now, if our pivot is a good pivot, so that means if our partition is good partition, so what is the time complexity? Then it will divide the array into this, then the time will be, because we are looking in one subarray only, and this is the cost for partition. Okay. And so, this will be order of n by the master method of case 3. Now, if it is not that much good, but if it is some ratio, if our partition is good in the sense that it will divide the array into very small part here and big part here, then also the recurrence is like this. So, we are looking at worst case. So, worst case we have to go for the longest subarray, and this will also give us linear time complexity. But what is the worst case? Because this partition we are using, now if we choose the pivot element always happening to be a minimum or maximum, if we, then the partition is always this, then the recurrence is this, and then this is order of n square solution, which is worse than the sorting and getting the ith smallest. So, this is the worst case for this algo. Okay. So, for the average case analysis, we can choose the partition as a random partition, and we can have a like randomized quick sort, we can have a randomized version of the select which is denoted by rand select. Okay. So, just our partition is a randomized partition, because we are choosing any element as a pivot. So, a comma a p comma q, this randomized partition means we are choosing any element as a pivot with probability 1 by n. That is the randomized version of this, and then we will do the same thing. K is equal to, K is the rank. So, K is equal to r minus p plus 1, and then if I is equal to k, then the remaining part is same. We return x, or the otherwise if I is less than k, then we called again this randomized select a comma p comma r comma I, otherwise means if I is greater than k, then again we have to call. So, then we call this randomized select on the right part of the array, but with I is equal to I minus k. So, this is the code. So, this is in this way we cannot come with some input where we are choosing the minimum or maximum as a pivot, because we are picking the element pivot as randomly on the runtime. So, this is the advantage here. Now, to analyze this code, let T n be the runtime of this rand select, then T n will be of the form. So, if the it will depend on the how the pivot is. If the partition is like this, if the partition is 0 is to n minus 1, if the partition is one is to n minus 2 like this. So, if the in general if the partition is k is to n minus k minus 1, sorry, it will be the maximum of these two, because we do not know, because we are only looking for only one part. So, we do not know whichever is the maximum of T 0 T n minus 1, this is also maximum of T 1 T n minus 2 like this. This is also maximum of T k T n minus k minus 1 plus theta of n. This is the maximum of this. So, like this. So, to get the expected value of this T n, we have to take help of indicator random variable. So, x k we defined as 1, if the partition is k is to n minus k minus 1, 0 otherwise. So, then T n will be written as summation of x k into maximum of T k T n minus k minus 1 plus theta of n, k is equal to 0 to n minus 1. Now, if you take the expectation of whole thing, and this can be shown as by some probability calculation which is out of our this course, this can be shown as theta of n. So, expected runtime is theta of n for this randomized version of the select, but worst case is always like this. So, we can always choose in the worst case the minimum or maximum element. So, now we want to make sure that in the worst case also we are choosing the good pivot element. Okay. So, that is the next algorithm which we will see. In the worst case, it is guaranteed linear time algorithm in the worst case, and this algorithm is by this 4% Pratt, sorry 5% Rives and Turgeon. So, they gave this idea in 1973. So, the idea is to get a good pivot. I mean, so that we can have a good partition which will partition the array into some part over here, some part over here. I mean, not the 0:n-1, it should be some little fraction over here guaranteed. So, that is the idea. So, idea is to choose a good pivot, select a good pivot. Okay. So, for that what we do? We have a array of size n, we group that into 5 elements group like this. So, like this 5 elements group, maybe last we have only 3-4 elements like this. Okay, we have a n element. So, we are grouping them this into 5 elements. So, roughly there are n by 5 groups. Now, we choose the median of each group, and that we can do just we have 5 element, we can choose the median, that is by constant time we can do. Now, after this we choose the medians of these medians, and that is our pivot element x, and that median, finding the medians of the medians, we will use the same algorithm recursively, select algorithm. We will come to know, we will see the select pseudocode recursively, and now this we are going to choose as a pivot. Now, if we choose this element as a pivot, what is the advantage? Advantage is all the elements over here are less than x, because all the elements they are basically less than this element and they are less than this element. So, all the elements over here are less than x, and all the elements over here they are greater than x. So, how many are there? So, there are n by 5 groups. So, among this is half half. So, n by 10. So, basically 3 n by 10. So, 3 n by 10 elements are less than x guaranteed, and similarly here 3 n by 10 elements are greater than x guaranteed. So, that means where is x? So, this is 3 n by 10 and this is 3 n by 10. So, x will be sitting somewhere here and this is guaranteed. So, that means we can ensure that we can guarantee that there are some portion here which are less than x, there are some portion which are greater than x. So, that is the good pivot. That means, we can ensure that it is not 0:n-1. So, we can guarantee that little portion will be here and remaining portion will be here. So, that is the way we select the pivot element. Okay. So, let us write the code for this, pseudo code for this. Okay. So, we call this as select capital. So, A is an array and we are trying to get the ith smallest element of this array. So, what we are doing? We are group the elements into 5 elements, element groups, and then find the median of each group, and so we have some medians. So, n by 5 medians. So, now we have to find the medians of the medians using the same select algorithm. Apply recursively, select to find the median of medians. So, we have n by 5 medians. So, from that you have to find the medians. Okay. So, we are using the same algorithm recursively. Now, we got the medians and that is our pivot. that medians of medians is our pivot. Okay. Now, we call the partition algorithm using this as a pivot. Maybe this is the pivot element, I mean we know the position of that. Okay. So, now we choose the rank of this element. Now, the remaining part is very same. So, k is equal to r minus p plus 1, this is the rank of this pivot, and then what we do? We do the same thing as our select was. If I is equal to k, then we return x, else if I is less than k, then we call this select on the left part of the array with the same I. Otherwise, if I is greater than k, this then we have to look at the, this is the divide and conquer approach. You have to look at the right part of the array q, but with so I minus k. So, this is the code for. So, this is now what is the runtime of this code of this. So, runtime. So, we are grouping the element into 5 element group. So, and then we are finding the median. So, here roughly we are spending constant time, and then we are applying the select algorithm to find the medians of the median. So, here size of the element is n by 5, and then we are calling a partition theta of n, and then this part is same as the select, and this part here our. So, this is 3 n by 10. So, in the worst case we are assuming that x is sitting here, and here all the elements are 3 7 n by 10, and in that, since we are looking at worst case analysis. So, worst case we have to look at into this sub array. So, this is basically T of 7 n by 10. So, the total runtime is basically what? Sum of all this. So, T n is basically T of n by 5 plus T of 7 n by 10 plus theta of n. Now, this is the recurrence of this code. Now, how to solve this recurrence? We can use the recursive tree to get the solution, or we can use the substitution method. So, that means we are assuming here that T n, we are looking for a linear time algorithm, we are assuming T n is less than C n, and this is true for all n, all k up to n. So, we will use this here. So, we got T n is, we will use this is less than C n by 5 plus C 7 n by 10 plus this. So, this is basically, so this is 9 C n plus theta of n. So, this is C n minus 1 by 10 C n minus theta n. Yeah. So, we can choose C, C is a constant which is in our hand. So, we can choose C big enough such that this will be positive. So, if this is positive, then this is less than C n. So, done. So, this is a linear time algorithm where, but this can be can also see by the help of recurrence tree, where this this we can get this linear time algorithm. So, now the question is whether this is better or the randomized version of the select is better. So, so this has so many steps, like we have to partition and we have to, but this is a guaranteed. This is a guaranteed worst case linear time select algorithm. Okay. But in the randomized version of the select, it is, although it is not guaranteed, but we can I mean it has been observed that it is giving some better result. So, we will prefer to use the randomized version of the select, although it is in the worst case it is not good. Okay. Thank you.